Guys, turn off your mics, please. No, that's bad. Okay.
You want the light bulb?
Yeah. Sure, if you want. Okay, so I'll start in a second. I'll go over what I assigned while I was gone on Tuesday. Oh. Hey guys, so test. Before I forget, test next. When do I get you Thursday? Yeah. Go ahead. I'm gonna start you. It'll be everything what we covered up to including models. So I'll go into more detail. It's on atomic theory, up to and including Bohr models for compounds. Which include the covalent and ionic. But it's slow loading. This doesn't end. Mood. This has got. There you go. Okay, next one, magnesium bromide. You know, I'm going to speed it up because I've lost a bit of time, so I'll just tell you. That's it. It's as simple as that. If it's a two-element, whether it's ionic or covalent, change the ending to ID. Later on, we'll name the covalent. Same rule applies. If it's two-element, change the ending to ID. Again, notice I didn't mention any numbers in the middle. None of these are multivalent. Next one, silver oxide. Instead of oxygen, change it to oxide. Next one, rubidium fluoride. Next one, silver iodide. You have to pay attention, guys, because I'm not writing it down. So, next one, aluminum bromide. Next one, calcium iodide. Metal always comes first. If it's ionic, we always state the metal first. Well, if there's a metal anywhere in there, it comes first. And Ga, I think, is gallium. Yeah. Gallium iodide. I, silver nitride. J, magnesium selenide. K, calcium phosphide. I'll spell this one out for you. I may write these out in the other class. So. H, I, J, K. Calcium phosphide. That's it. Next one, sodium oxide. Next one, cadmium sulfide. I'll write that one out for you as well. Lost my connection. One of those days. I'm not going to get upset. I'm not going to get mad. I'm going to throw my computer out the window. Yeah. Next one, page 190. No, did I do that one? 180. 188? I got it. Thanks. Okay, write each of the following. The formulas. The formula tells you the elements and the number of ions for each element. How do you figure that out? Where the crisscross comes in. You've done this before. If the charge is the same, you just write down the symbols. Okay? If it's a +1, -1, if it's a +2, -2, just write down the symbols. In this case, it's a +1, -1. Just write down the symbols, NABR. This is a little harder. This is where you use the crisscross. If the charges are not the same, then you crisscross. Put the 2 there and the 1 there. So you get ZN. I know, we're not going to show the 1 in a second here. I'm going to erase it. ZNI2. I don't need to, if there is a 1, I can just I don't need to show it. It's there. It's implied. What does this mean? It means, yeah, it means one zinc. It's one zinky. One zinc. For every one zinc, there's two iodide. Next, K plus 1, sulfur minus 2, crisscross. The 1 there. We put the 2 there. You don't have to show the 1. Potassium sulfide. Next, again, whenever there's different charges, unlike charges, you have to crisscross. Put the 2 there. 2 there. Easy is easy. Same charge, CaO. Same value, not obviously opposite charges, but same value. 2 and 2. Same thing with F. We just write ALP, because both of them have a unit of 3. Okay. Now, on a side note, if I had this, and it does happen, if I have a 4-2 combination, so that would imply put the 4 there, put the 2 there. The rule is if you've got a 4-2 or 2-4 combination, reduce it. Divide by the common factor in each 2. Reduce it to just, and again, you don't have to show the 1. 3, 6, same thing. Divide by 3. 2, 4, 3, 6. Okay, write the formulas of the following ionic compounds. Strontium nitride. So we'll need a periodic table for this. We can look it up. Strontium's got a +2. No? Nitride refers to nitrogen, has a -3. Crisscross, put the 2 there, 3 there. There you go. Next one, lithium oxide. Lithium has a +1. Oxygen -2. Crisscross. I'm going to stop showing this in a while here just to remind you I'm doing this. Make it more clear. Li2O. C, silver sulfide. Ag, look it up. Silver's got a +1. It's in the middle. Column 11. Sulfide refers to sulfur with a -2. Crisscross, you get Ag2S. D, barium phosphide. +2. Phosphide refers to P, phosphorus, which is -3. Crisscross. Sorry, guys. I'm going to have to. Give me a second. It's cold and bugging me. Take a little mini break here. 20 seconds. Okay. E, sodium nitride. Sodium nitride. Again, crisscross, Na3. You need 3 sodium for 1 nitride. That's what that means. Because it means the formula tells you nitride. Proper expression is the ratio of the ions. What I just wrote down is the ratio of the ions. You'll see that expression, ratio of the ions. Okay, 3 sodium for every 1 nitride. Potassium selenide. I don't know what selenide is. Selenide is -2. Interesting. Okay. Crisscross, and you get K2SE. I'm writing small. Next, cesium sulfide. DS2S. H, aluminum nitride. They both have the same charge, which means simply write down the symbols, Al and N. That's it. You don't have to crisscross. Zinc oxide, Zn. I think zinc's got a what, +2? Same charge. So you write down ZnO. Aluminum iodide. Crisscross, you get Al-I3. Lithium fluoride. Same charge, LIF. Al, sodium sulfide. that right? Is that correct? You sure? I'm not sure either. There you go. Zinc phosphide. I would make sure you know you're familiar with the proper expression for phosphorus once it's part of a compound. It's phosphide. You'll hear different expressions later on. Phosphate, phosphite. That's distinct. This one's a phosphide. Oops. What do you think? Good job, Mr. C. No? No. What do you think? Even worse? I try. Yeah, you're right. I'm wrong. Yeah, crisscross. The column is changing here. Okay. And magnesium chloride. Yeah. So it's Mg plus 2. Chloride minus 1. Oh, rubidium plus 1. Bromide minus 1. Okay. Okay, now we're on to multivalent. Sure. Multivalent ions. They're all metals. Only metals. They're all found in the middle, in the transition metals. I mentioned this to you before. So let's look at some examples. Most of the transition metals, not all of them, are what we call multivalent. Means they have 2 or more charges. If you take a look at the upper right-hand corner of each element in the blue section, in the middle of the periodic table, most of them have 2 or more options in the right corner. So let's look at titanium. That's my favorite one. Titanium, the lightest metal ever. Well, lightest as far as strong metals. Very strong, very light. Notice it's got 2 options, a +4 and a +3. We have titanium. And if you look in the right-hand top corner, +4, +3. It doesn't matter if you put the plus before or after. It's the same idea. There's 2 options. What that means is there's 2 possible compounds that can form with any one nonmetal. This is most common. Charge at the top is the most common one. So, for example, I could have a titanium (4) chloride. We'll get more into this later. This, just for a reminder, is the Roman numeral 4. I'll go through all of that in a bit. Or I could have titanium (3). That's pretty obvious. That means 3, Roman numeral 3. Same thing, chloride. Same Same words, different numbers in the middle. Two different compounds. That's what it means to say it's multivalent. It can form different compounds with the same nonmetal. So the formula for this is TiCl4. Formula for this is TiCl3. Different compounds because of different formulas. Different ratio of ions. You need 4 chloride here. You need 3 chloride here for every 1 titanium. Multivalent. Metals with more than 1 possible charge. Usually it's 2, it can be 3. How do you know which ones? How do you know if the compound has a multivalent ion or not? You have to be aware of it. You have to check. If you're given, let's say, a name, it'll be obvious. So I'm going to go through some of the examples. If you're given, let's say, one sec. If you're given the name, it's obvious. You'll know it's multivalent right away. So manganese 4 sulfide. Sometimes it's spelled with an F, sometimes it's spelled with a PH. Doesn't matter. PH is a British. It's a reminder that it's multivalent. It tells, this is actually easy. It tells you, you don't even have to look it up. It tells you what the charge is. So what are the corresponding numbers that we're going to be using with Roman numerals? I write them down. We don't go much higher than that. Maybe 6, maybe 7. I'll write down up to 7. I doubt we'll get to 7, but in case. 2. Right? 5 is a V. Five is a V. And then, so one, if you see a 1 before the V, 1 before any Roman numeral means that number minus 1. So this is 5 minus 1. If you see the little 1 after the Roman numeral, in this case, V plus 1, 5 plus 1, 6. 2 1s means plus 2. That's it. Okay, back to this. So write it out. Mg, or Mn, pardon me. Mn is manganese, plus 4. Sulfur is minus 2. There's your 2-4 ratio. We're going to reduce it in a minute here. So crisscross, you get Mn, S4. Then you reduce it. Divide both by 2. And you get MnS2. That's your final formula. Okay. Let's look at this. Cobalt 3 oxide. How'd they get cobalt 3 oxide? That tells you the charge. That tells you, if you look up cobalt, it's in column 9. It has two options. Either cobalt has two options, either a +2 or a +3. This is telling you which one it is. It's a +3. So it's cobalt 3 oxide. Write down the oxygen -2, crisscross. And you get CO2, oxygen 3. Try those out on 190. See if you can do those. We'll go through them in a sec. Not running away, just don't want you to see me falling. Okay, take a few minutes to do that.
For the test, are we gonna?
I'll go into more detail, but tonight. But
Are
yeah,
we gonna get like one of these sheets?
yeah, you've got. You don't need it for. Let me just see when you're printing.
And then I
Yeah,
have like the
you don't. You got it actually.
last.
That's a polyatomic guide. You got it already on your on this. You got it here.
Oh, I couldn't find it in there.
Really?
Yeah. It was like missing.
Just show me your. Well, I can make another copy if I have to. I mean that. I'll announce to the whole class. Guys, for the test. You have, first of all, I'll give you a more thorough breakdown tonight, a little more detail. Secondly, you need to always have this data booklet with you on hand. You're going to use them for your test, so don't lose it. Apparently, some people are concerned about the second page. You won't need the second page for this test. However, you will need it for what's coming up. Some people, if you didn't have a proper copy made, if for whatever reason the second page says polyatomic ions didn't show up, let me know. I'll make another copy for you. You didn't get it, Joey? You didn't, yours? Yeah, yours is okay? Yeah. So, anyways, let's go through this. So, guys, ladies and gents, you're seeing a common theme here. Mr. C, blah, 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 blah. Mr. C, why'd you give me 0? Because you're talking. Okay. You're seeing a common theme that you'll see throughout chemistry and actually physics as well. The idea of neutrality. These charges come together in a way so that they match each other. They'll combine in a way so that they always add up. Neutrality gives you a we see that throughout nature. Whatever the system is, whatever it is, whether it's a molecule or even some object in space, it always seeks out the lower energy state. Neutrality is a lower energy state. Something to be aware of. Okay, so let's go through this. Page 190. Write the formulas for each. These are actually easier than the previous one. You don't have to look up the charge for the metal. This is the easy part. What comes next is a little harder because, well, you'll see why. But let's just go through this quickly here. So I'll write down the charges to begin with, and then I'll speed it up a bit. So you crisscross, you get Cu3N. Iron-2 phosphide. So this is Fe. Phosphide is just P. as opposed to what you're going to see later on, which is phosphate. That's something different. It's phosphide, it's just P. Well, crisscross. Next, manganese is Mn, not Mg. Manganese is Mn. Oxide -2. Same charge, just write down the symbols. What is each of these? These are called formulas. Again, they're telling us the ratio of ions. I keep repeating myself, but that's not a bad thing. Ratio of the ions. I'll just put ratio of ions. You need the first one, 3 copper for every 1 nitride. Okay, notice different type of manganese. 4 compared to 2. Now we got a crisscross. We're not done, but we do this first. And then reduce. If it's a 2,4, divide by 2. If it's a 3,6, divide by 3. That's a proper formula in its reduced form. If you wrote Mn2O4, you wouldn't get full marks. So make sure you reduce it. Look at the charge. Charge here is +2. Charge here is +4. Take a look at the table. Manganese is column 7. Those are 2 of the possible charges. Right? 2 or 4. 2 being the most common. It's right on top in the chart, in the periodic table. E. Chromium 2 bromide, I'll just give you, it's CrBr2. Compared to chromium 3 bromide, which is CrBr3. Lead 4 chloride, PbCl4. H, iron 3 phosphide, Fe, FeP. They're both a charge of 3. One is plus, one is minus. I. Tin 2 sulfide, tin is Sn, it's SNS. They both have a charge of 2. Oh, like that. Tin 2 nitride, SN3N2. Tin 4 nitride. So SN3N4. Different compounds because of the different formulas. The ratio of the ions are different. Mercury 2 fluoride is HgF2. Copper 1 iodide, Cui. Copper 2, Cui2. Copper 2 selenide. I look up selenide and I think it's -2, right? Yeah. So it's just CuSe. Now the harder part. We have time. Yeah, I'll do a little intro. So this is the harder part. Naming compounds. Yep. You lost connection? What? I'll just talk to myself. How does that? Naming compounds that contain. Rain, you left me, man. Every Skinwalker Ranch. Yay! Okay, so here we go. Let's look. Now we are going the opposite direction. We're given the formula. You have to name the compound given the formula. So here's the hard part. When you're given a formula, check the metal. If it starts with a metal, you know it's an ionic. You know the rule, change the ending to IDE if it's a 2-element compound. But the rule is this, in general, if you're in doubt, check the metal. What do I mean by that? Look in the blue section, see if it's in the blue section. And if it is in the blue section, check to see whether it has 2 or more possible charges. Check to see if it's multivalent. That's the rule. Unless you're confident. You know the elements in the first 2 columns, then you know those columns there, none of them are multivalent. But if you're not confident, check to see where the element is. If the metal's in the middle, check to see whether it's multivalent. Okay, gold is multivalent. You can look at gold and you can see it's got either a +3 or a +1. So what does that mean? Well, this is what you do. I would name it the way you'd normally. So write down gold and put a space in between because you know it's multivalent. It's going to be a Roman numeral there. So that's the first part. So if you get anything else wrong, at least you get marks for that. Now, here's the hard part. What goes in there? Go back to the formula. And reverse the crisscross. Gentlemen, this is hard, so pay attention. Focus. Focus. Hello. Put the 3 there. There's a 1 there. It's not shown. Put the 1 there. So when I write it down, and I'm not done necessarily, I get AU plus 3 and minus 1. Now, here's the second rule. That's the first rule. Reverse the crisscross. So first rule, reverse crisscross. You're not always done. There is a second step. You may have to do the second step. How do you know when you have to do the second step? Check. Yeah. I know. Crap, right. I was looking at the old schedule. I will. Listen, your homework. I'm going to finish this. Do page 191. I'm going to talk to myself. Go. I like talking to myself. Check the non-metal, the charge of the non-metal. Guys, can you keep the noise at a minimum? I'm talking to myself. If it's correct, then the charge, oops, people are talking, and the charge on the metal is correct. Guys, make sure you watch the ending of this recording. See ya. If, there should be a capital, if, take care, the charge on the nonmetal is incorrect. Take care. Multiply both charges
Julio Valenzuela, please come to the front office.
by the
Julio
correction
Valenzuela to the
factor.
front office, please.
So what do I mean by correction factor? Let's go back to this equation here. So nitride has a charge of -3, not -1. So I have to multiply it by 3. I have to do the same thing with the gold. Oh, I made a mistake with the crisscross. I was going too fast here. This is +1 when you reverse it, and this is -3. Okay, so this is correct. I don't have to do anything. I don't have to do anything. That is the Roman numeral I placed in the middle of the name. So if I go back to the name, I'll write gold 1 nitride. Let's look at the next one. Palladium and then sulfur. So if I were to name this, it would be palladium sulfide with a number in the middle because I know this is multivalent. If I check it out, palladium has 2 possible charges. Palladium has 2 possible charges of 2 or 4. So I don't know which one that is. So I go back to the formula. I reverse the crisscross. Put the 1 there. Put the 2 there. So I get PB plus 2S -1. This is not the correct charge for sulfur. I have to multiply it by 2 to get the correct charge of -2. Whatever I multiply the right charge by, I multiply the left charge by. So this is 2 times 2 becomes 4. So the correct name is palladium 4 sulfide. So just to highlight, I was going a little fast here. When you reverse the crisscross, you get, I made a mistake here, you get a +1 and a -3. This is the correct charge. I don't have to do anything after it if the charge on the nonmetal is correct. If it's not correct, as it was in this case, originally it was when I reversed the crisscross sulfur -1, I have to multiply it by a factor to make it correct. In this case, multiply by 2. Whatever I do on the right, I do on the left. I multiplied the 2 on the left by 2 to get +4, which becomes my Roman numeral. I'll do more of these next day. Just complete page 191.